Okay, so today we're doing vectors and their component form. So we're on a new topic, and this little cartoon guy is going to help introduce it. In a movie, he calls himself Vector, and this is his line. I go by the name Vector. It's a mathematical term represented by an arrow in both direction and magnitude. So it kind of introduces our new topic. Yes, we are working in math class with vectors, and yes, we're going to talk about direction and magnitude. So the arrow is a directed line segment, okay, such as vector PQ. Okay, and it's kind of not showing up on my slide right now. I had to update all the mathematical symbols, so it should be an arrow there. Where point P is the initial point, emphasizing that, and Q is the terminal point. And we put the arrow there at the terminal point. The magnitude or length is denoted by this double vertical bar, and you write vector PQ in there. Draw in the arrow. It's, again, not updating, so that's supposed to be an arrow. If vector PQ is a vector in a plane, it is denoted by, it actually says vector U, vector V, and vector W. Okay, so let's call this one vector U. When you write it, draw the arrow above. Sometimes you see it in textbooks and workbooks, and it's boldface. It still reads as vector just as much as the arrow does. Okay, so the first thing we see at the top is an importance notes. Please write it down. Directed line segments that have the same length or magnitude. Length and magnitude mean the same thing. And direction are called equivalents. Okay, and in example 1, it's kind of tied into our do now. So hopefully you did do that. So we're making vector U be represented by the directed line segment from point P to point Q. And point P is the origin, point Q is 3, 2. So we actually worked in the do now to find the distance of vector U, which is vector PQ. And the distance should have been the square root of 13. And our slope, if we were to find the slope between these 2 points, you may or may not have done it in the do now, easily comes to 2/3. I say easily because we do know how to find slope. All right, now it says, and let vector V represent the directed line segment from point R to point S, and it's from the point 1, 2 to 4, 4. So this is what we did in the do now. We found the distance between the 2 points. And again, you may or may not have found the slope. So slope isn't so easy if it's not the origin. We do y sub 2 minus y sub 1 and x sub 2 minus x sub 1. But the computations are at least easy. So show that vector U is equal to vector V. Well, we kind of did all of that hard work already. Okay, so we found the direction because the slope of vector PQ was equal to the slope of vector RS. So once we found that those two slopes were the same, that means they're going in the same direction. Okay, and magnitude. Okay, we found the magnitude, or if you want to call it length, it does not matter. And it turns out the magnitude of vector U is equal to the magnitude of vector V. So once we're able to state that, we indeed show that vector U is equal to vector V. Okay, we did it. All that hard work from the do now, and a little bit more. But we should be good with example 1. So we're going to move on to a couple more examples that talks about component form. So these 2 slides bring us to component form of a vector. First talks about standard position. So the standard position of vector v is a vector whose initial point is the origin. Very important. We like working from the origin. It's really easy to work with. So like vector PQ, or if you want to call it vector U in example 1, is in standard position. Okay. The coordinates of the terminal point are v sub 1, v sub 2. Okay, when it's in that standard position. This is the component form. Okay, and when you do indicate a component form, we use these arrows on either side. Yes, it's a different type of arrow indication. It's actually called a chevron. It's a little bit more complex to call a chevron if you don't know what it is. So most students just call it like arrows on each side, but they are chevrons. And it indicates v sub 1 and v sub 2. V sub 1 is a component of vector v, and v sub 2 is a component of vector v. Okay? All vectors have component forms. Like if you say vector u, vector v, vector w, that means that they're already in component form. And you can have different indications if they're different letters. Okay. All right. Well, with that being said, hopefully you got that part down. When we stop, pause the video if you missed something. So now we're going to talk about getting it into this component form. That's super duper helpful and important. Okay. So the component form of a vector, if you're given the initial point P and a terminal point Q, that's what we call it. P is P sub 1, P sub 2, and the terminal point Q is Q sub 1, Q sub 2. Then the component form of vector PQ, I can actually see the arrow here. Yay! That came up. Is in the chevrons, Q sub 1 minus P sub 1, comma, Q sub 2 minus P sub 2. So it's just terminal minus initial. Terminal minus initial. Every time you do component form, you say terminal minus initial. Okay? And then that's how you get it into component form. Where's my chevron? There it is. Okay, so of course we're going to have an example, but before we do, when it is in component form, that makes finding the length or the magnitude of vector v easier. Okay, if it's not, you still can find the length or the magnitude of vector v by using the distance formula. So this is something you guys kind of did in the do now. Okay, it's just with the notation of the terminal minus initial. And now I want you to copy down here what it is with your component form. So make sure you get that down while I erase this. All right, so another note, I'm going to give you a minute to get down that note. All right. So the magnitude of vector v is the square root of the quantity q sub 1 minus p sub 1 squared plus the quantity of q sub 2 minus p sub 2 squared, which is equivalent to the square root of v sub 1 squared plus v sub 2 squared. This is, of course, understanding the component form. You already copied this. This is just a duplicate. All right, so the note here, if vector v is in component form, and you find that the magnitude of vector v is 1, we call that a unit vector. If vector v is the zero vector, where the initial point and terminal point is the origin, then the magnitude vector v is 0. So again, if the initial and terminal point is the origin, it's called a 0 vector, and it is at the origin. All right, I think we're ready to go for our examples. Okay, so these are the examples that I promised you from talking about component form. So example 2, find the component form and length of vector v that has an initial point of 4, -7 and a terminal point of -1, 5. So when it says initial point, it's the same thing as like p. So we got a p sub 1, p sub 2 there if you want to label it. I'll do that for you if you want. And terminal point, -1, 5. So this is the same thing as saying we have point Q here, and that's Q sub 1 and Q sub 2. Okay? So we want to find vector v in component form and then its length. All right. So here we go. We're going to do terminal minus initial. Okay, so terminal minus initial would be -1 minus 4, comma. Terminal minus initial, that would be 5 minus the -7. Okay, so our final answer for vector v in component form is -5, 12. Okay, gotta squeeze that in. Now we get to do our length or magnitude of vector v. So here we go. Since we already found it in component form, we're just going to take the -5 and square it, and the 12 and square it. And that gives us 169. And the square root of 169 can be exactly 13. Okay? If you can't simplify your radical, then you can just leave it in radical form, but at least leave it in your simplest radical form. This is example 2. Okay, sorry for not labeling that. Let's do example 3. All right, example 3. There it is. So vector PQ has an initial point of 0, 0 and terminal point of 1, 3. Vector RS has an initial point of 0, -1 and a terminal point of 1, 2. Are they both equivalent to vector v, which in component form is 1, 3? All right. Do pause the video to copy down the problem because I'm writing out the work and the answer. I want to make sure you understand I get it. You know, you need to have the problem too. That's uber important, so you can make some practice problems and work on them when you study. All right, so here we go. We're going to first find vector PQ and its component form. And so we're going to do terminal minus initial, and we find that it is 1, 3 in component form. So vector PQ is equivalent to vector V. I'll write a little therefore. Now let's do it again for vector RS. Okay, we're going to do terminal minus initial. So we find that vector RS is 1, 3. So vector RS is vector V as well. Okay, so therefore, okay, they are both equal. It's vector V. All right, good luck.